Welcome to our deep dive, everybody. Today we're going to be talking all about Kimi K1.5.
Okay, Kimi K1.5.
We're going right to the source material.
Wow.
We got the Kimi team's technical report right here,
Mm-hmm.
and we're going to try to figure out what makes this AI model so groundbreaking.
Yeah.
From what I've seen, I mean,
Yeah.
it's tackling reasoning, it's tackling coding, even understanding images,
Yeah.
like
They're pretty amazing.
pushing the limits of what we thought AI could do.
Yeah, it's definitely it's causing a stir in the AI community. It's they're exploring this new way to train AI
Okay.
using reinforcement learning, RL,
Okay.
and instead of relying on these massive data sets,
Yeah.
Kimi learns by actively exploring and getting rewarded for correct answers.
Hmm.
Kind of like how we learn from experience, right?
Yeah.
If you do something good, you get a reward.
So it's not just about the data, it's like the doing.
Exactly. It's
Okay.
all about the doing.
That's a pretty different approach from like the usual data-heavy methods we see in AI.
It is. It is. It's a very different way of thinking about it.
And they're doing some interesting things with something called context too, right?
Yeah. So context in AI is all about how much information the model can keep in mind at once.
Okay.
So Kimi K1.5 can handle a massive 128,000 tokens, which is, to put it into perspective, like the length of a short novel.
Wow.
I mean, that's crazy. Most AI models, they have a much smaller context window.
Right.
So to be able to handle that much information, it's really impressive.
So it's almost like it's not just memorizing stuff. It's like it's understanding the relationship between all those pieces.
Exactly. It's understanding the connections, the relationships between everything it's seeing.
So with all that information at its fingertips, like it's no wonder Kimi can tackle complex reasoning, right?
Yeah.
The report mentions they're also using something called policy optimization.
Mm-hmm.
What's that about?
So imagine Kimi is like a student learning a new skill, right?
Okay.
Policy optimization is like the coach guiding its learning process,
Yeah.
making sure it's learning effectively. And Kimi uses this modified version of a technique called online mirror descent, which helps it learn more efficiently and become more robust in its reasoning.
Okay, so it's not just about stuffing Kimi with information.
No.
It's about teaching it to learn effectively.
Exactly. You got to teach it how to learn.
Right, yeah.
You can't just, throw data at it and hope for the best.
It was like a good teacher, right?
Yeah, like a good teacher.
Guiding the student.
Guiding the student, exactly.
Okay. But the report also mentions that Kimi isn't just a text whiz. It can understand images too, right?
Yes. And this is where things get really cool. Kimi is a multimodal marvel. It's trained on both text and visual data.
Wow.
It's not just reading, it's seeing. And the results, they're pretty impressive. Kimi can answer questions about pictures. It can understand charts.
Right.
It can even take on visual coding challenges.
So we have this AI that can reason, it can code, it can understand images. I mean, how do we know that it actually works well in practice, though?
Yeah, good question. So the Kimi team, they put K1.5 through a battery of tests. They use a whole bunch of different benchmarks.
Oh, okay.
And the results, they're pretty remarkable.
Okay, don't keep us in suspense. Give us the highlight.
Okay. So Kimi, it aced some really tough math and coding tests, like the AM. That's a high school math competition.
Yeah.
And Codeforces, it's a platform for all these like competitive coders.
Okay.
And Kimi's scores, they weren't just good; they were state of the art. Which means, we're reaching a point where AI can solve problems that even human experts, they struggle with.
So it's not just beating other AIs. It's like
No.
it's performing at a level that rivals the best human minds.
Exactly. And on tasks involving visual reasoning, Kimi's performance actually matched that of OpenAI's powerful model.
Wow.
Which is a huge achievement.
So it's like up there with the top AIs.
Oh, yeah. It's definitely up there.
That's really impressive. But I did notice in the report there was also a mention of Kimi's tendency to, quote unquote, overthink.
Yeah.
What's that all about?
So as Kimi was learning its responses, they started getting longer and longer, and sometimes a little too long, It's like almost as if Kimi was trying to show off all of its knowledge,
Right.
even when a simple, concise answer would have been enough.
Like it was like that friend that can't answer a simple question without giving you a lecture.
Exactly. That's a great analogy.
Yeah.
So to deal with this, the Kimi team, They introduced a length penalty during training.
Right.
It's basically, teaching Kimi to value conciseness and clarity in its responses.
Yeah. Being smart is great, but being able to communicate effectively is just as important.
Absolutely, absolutely.
How did they actually get Kimi to be more concise though? What was the trick?
They use a technique called long to short to transfer knowledge from the long context version of Kimi to smaller, more efficient short context models. It's kind of like, distilling all of Kimi's wisdom into this more concentrated form.
Okay, so they basically taught Kimi to be brilliant and articulate.
Exactly. They taught it to get to the point, which is important, right?
What does this mean for Kimi's performance in real-world applications, though? Like, can we actually use this thing?
Yeah. So this long-to-short method, what it does is it allows Kimi to excel even when there are limitations on processing power.
Okay.
So imagine being able to access Kimi's capabilities on your phone or your laptop. It opens up a whole world of possibilities.
So they essentially made it more practical.
Exactly.
That's pretty cool. But it sounds like training Kimi must have been a pretty complex process. Can you tell us a little bit about how they actually built this AI powerhouse?
Yeah, so one of the most impressive things about their work is just the sheer amount of effort they put into the data curation.
Okay.
The Kimi team was really meticulous in selecting and preparing the training data because, garbage in, garbage out.
Right. So it's not just a matter of throwing any data at the model.
No.
It's about being selective and strategic.
Exactly. You want to make sure the AI is learning from the best possible sources. For the visual training, they use this mix of real-world images, synthetic visual reasoning data, and even some text-rendered data.
Text-rendered data? What is that?
So they basically took textual information and converted it into visual formats, like screenshots or photos of text.
Why would they do that?
It's a clever way to maintain consistency.
Okay.
Because when Kimi sees text in an image, it needs to understand it the same way it understands text.
Right.
That's just written out.
So it's like teaching Kimi to understand text in different contexts.
Yeah.
Regardless of whether it's presented as words on a page or part of an image.
Exactly. Consistency is key.
Okay, makes sense.
And when it came to the code training, they went above and beyond. They automatically generated test cases, even for problems that didn't originally have them.
So they're like setting up these mini challenges for Kimi.
Exactly, like mini exams.
Okay, to test its coding skills.
Exactly, to make sure it's not just memorizing patterns, but actually understanding how to solve problems.
Got it.
But what's really impressive is how they tackled evaluating Kimi's math skills.
Evaluating math. I mean, that sounds pretty straightforward. Isn't it just about checking if the answer is right or wrong?
It's a lot trickier than you might think because, you can have different written forms that represent the same answer, like a squared minus 4 and a plus 2 times a minus 2 are both correct ways to express the same mathematical idea.
That's true. I remember struggling with that back in algebra class. So how did they account for that?
They developed two types of reward models for math. A classic one, and a more advanced chain of thought model.
Chain of thought.
Yeah, so this chain of thought model, it's really cool. It actually generates a step-by-step reasoning process before deciding if an answer is right or wrong.
So it's not just looking at the final result, it's examining the logic behind it.
Exactly. And their manual spot checks showed that this chain of thought reward model was super accurate, like 98.5% accuracy rate.
That's impressive. It seems like they really thought of everything when it came to training and evaluating Kimi K1.5.
You did a great job.
But I imagine all this complex training must have required some serious computational muscle.
Yeah.
What can you tell us about the infrastructure they built?
So their RL training system, it's a marvel of engineering. It can handle the massive challenges of long context reinforcement learning at a huge scale. One of the key things they did was use partial rollouts.
Partial rollouts.
Yeah, so imagine you're working on this giant jigsaw puzzle, right?
Okay.
Instead of trying to force all the pieces together at once, you break it down into smaller sections.
Right.
That's essentially what partial rollouts do.
Got it.
They divide Kimi's long responses into segments that are processed over multiple iterations.
So it's like breaking down a complex problem into smaller, more manageable chunks.
Exactly, makes it much more efficient. And to make things even faster, they implemented techniques for reusing previously generated segments.
So they're recycling parts of the puzzle that have already been solved.
Precisely. They're not wasting any time.
Smart.
And then there's another really cool part of their infrastructure, the code sandbox.
A code sandbox. What's that?
Think of it as a secure playground for Kimi to test out its coding skills.
Okay.
It's a virtual environment optimized for code execution and benchmark evaluation.
So Kimi can try out its code in a safe and controlled environment.
Exactly. No risk of causing any real-world problems.
It's like a virtual testing ground.
Yeah, virtual testing ground.
Mm-hmm.
And it's incredibly versatile. They can dynamically switch container images to support all sorts of use cases.
So they basically built a playground that can transform itself depending on what Kimi needs to learn.
That's a great way to put it.
It sounds like the Kimi team really went all out to create this robust and efficient training and evaluation system.
They definitely did.
They've clearly put a lot of thought into every aspect of Kimi's development.
Yeah, and, the way Kimi learns, it actually has some really interesting implications for how we humans learn and solve problems.
Okay, now you've got me curious. But I have a feeling you're going to make us wait to hear about that.
You know me too well. We'll dive into those implications in the next part. But first, we need to explore some more of Kimi K1.5's amazing capability.
You're killing me with the suspense. All right, let's uncover more about what this AI powerhouse can do. Welcome back to our deep dive into Kimi K1.5. Before the break, we were about to hear how Kimi's learning style might impact human learning.
Right. Well, one of the things that makes Kimi so effective is its ability to, explore, experiment, and learn from its mistakes, all while working with this vast context of information.
So that whole reinforcement learning approach, right?
Exactly. It's not just passively taking in data, it's actively engaging with it.
Right.
And that process, even though it's, much faster in Kimi, it has some interesting parallels to how we learn best as humans.
Okay, yeah.
Think about it. We don't really learn by just sitting back and listening.
No.
We learn by doing, by trying out ideas, by, making mistakes, figuring out how to do better next time.
So by looking at how AI learns, could we find new ways to improve how we learn?
Exactly. I mean, take Kimi's ability to hold this massive amount of information in context.
Right.
That could inspire, whole new teaching methods that focus on connecting ideas and building deep understanding rather than just memorizing facts.
So instead of cramming for a test, you're like building a web of knowledge.
Exactly.
Where concepts are linked.
Yeah, a web of knowledge where things are connected.
Imagine a classroom where learning is more about exploration and discovery.
Yeah.
And it's guided by an AI that tailors the challenges and feedback to each student's needs.
It's like having a personalized AI tutor for every student.
Each student could learn at their own pace, focus on the areas where they need the most help.
Absolutely.
Yeah, that would be pretty amazing. And Kimi's success with multimodal learning, that could encourage a more well-rounded approach to education, right?
Absolutely.
Where it's not just text and lectures.
No, not at all.
You could have visuals, sounds, even movement, and hands-on activities.
Right. Think about interactive simulations, visual models of complex concepts.
Yeah.
Or even, building and programming robots.
That would make learning more engaging and effective for all types of learners. It's like taking the best parts of how AI learns and applying them to how we teach and learn.
Exactly.
That's a future of education I can definitely get behind.
Right.
Of course, we have to remember that AI models like Kimi are tools.
Right.
They can help us learn better, but they can't replace human qualities like creativity, critical thinking, our ability to connect with each other.
Exactly. Those things are irreplaceable.
Yeah, for sure.
Yeah.
We wouldn't want to lose those uniquely human aspects of learning and teaching. It's about finding the right balance.
Absolutely.
Using AI's strengths, but preserving what makes us human.
Finding that sweet spot.
Exactly. All right, let's shift gears a bit and dig into some of the technical details that make Kimi K1.5 so impressive. You mentioned earlier context.
Right,
context. The amount of information the AI can hold in its mind.
Yeah.
The bigger the AI's mental workspace, the better it can reason and solve problems.
Exactly. And the Kimi team actually trained models of different sizes.
Okay.
Some with shorter context windows, others with longer ones, to see how it affected their performance.
So was there like a clear winner? Did the bigger context always win out?
Well, the findings were interesting. They found that even smaller models, when they were trained with these longer contexts,
Okay.
they could achieve performance levels similar to much larger models that had shorter contexts.
So it's not just about raw computing power, it's about how effectively the AI can use the information it has available.
Exactly. Exactly. It's about, making the most of what you've got.
Like how a really skilled chess player can beat someone with a more powerful computer.
A perfect analogy. However, they also found that those bigger models, when combined with long context, they generally had better token efficiency.
Token efficiency, what does that mean?
So think about it like writing an essay. A token-efficient model can communicate the same information using fewer words.
Okay.
So it's more efficient.
Got it.
It's faster.
So those larger models with long context are like the high-performance sports cars of the AI world.
Yeah, a great way to think about it.
Powerful and efficient.
Now, their research went even deeper. They also investigated the role of negative gradients in the learning process.
Negative gradients. That sounds a little technical. Can you explain that?
Okay, so imagine you're training a dog a new trick.
Okay.
You reward the dog when it does something right.
Mm-hmm.
Maybe you gently correct it when it makes a mistake.
Right.
Those corrections, they're kind of like negative gradients in AI training.
So it's like the AI gets a virtual pat on the head for good decisions.
Exactly.
And a little nudge in the right direction when it makes a mistake.
That's a good way to put it. Now, some AI researchers believe that we shouldn't use negative gradients at all.
Really? Okay.
They think that by only rewarding good behavior, the AI might be more free to explore different solutions and come up with more creative ideas.
So it's like giving the AI more freedom to experiment without the fear of being penalized for trying new things.
Exactly. So the Kimi team, they wanted to test this out. They compared their approach, which does use negative gradients, in another method called REST, which doesn't.
So did the tough love approach win out?
It's interesting. The results showed that using negative gradients was actually more efficient overall. Their model learned better and faster compared to the REST method.
So even in the world of AI, a little bit of constructive criticism can go a long way. But there's another aspect of training I'm curious about. Sampling strategies. What does that mean in terms of AI?
It's all about how you choose the data you use for training. Remember, the Kimi team, they had this data set with a wide range of problem difficulty.
Right, from easy to incredibly hard.
Exactly. They wanted to make sure that Kimi could handle, all sorts of challenges.
Right, but isn't it best to just randomly select problems from the data set?
Not necessarily. The Kimi team, they took a different approach. They were inspired by how we learn as humans. So they used something called a curriculum learning approach.
Curriculum learning.
Yeah. So they started with easier problems.
Got it.
And gradually introduced more challenging ones as Kimi's skills developed.
That makes perfect sense. You wouldn't teach someone advanced calculus before they even understand algebra.
Exactly. You got to build a strong foundation.
And it turns out this approach works just as well for AI as it does for us humans.
It does. Their research showed that this curriculum learning method significantly boosted Kimi's performance compared to just randomly selecting problems.
Wow. It seems like they really cracked the code when it comes to training and evaluating Kimi.
Yeah.
They've created this incredible AI that can reason, code, understand images, and even learn in a way that mirrors how humans learn.
It's pretty amazing what they've accomplished.
This deep dive into Kimi K1.5 has been fascinating. It's clear that AI is advancing at an incredible pace, and it's going to have a profound impact on our lives. But I'm also curious to hear your thoughts on the bigger picture.
Okay.
Where do you think Kimi's success tells us about the future of AI as a whole?
That's a great question, and one we'll be exploring in our final segment. Stick around as we delve into the future of AI and the possibilities that lie ahead.
Welcome back to our deep dive on Kimi K1.5. We've talked about its tech, its achievements, and even how it might change how humans learn.
It's been a journey, hasn't it?
It really has. But I'm curious now about the big picture. Where do you think Kimi's success points us in terms of the future of AI?
Well, I think we're on the edge of a major AI revolution, wouldn't you say?
Yeah, definitely.
Kimi is showing us some really key trends. For one, reinforcement learning as a way to train AI is powerful, really powerful. Kimi can reason, code, even understand images. It shows how flexible this approach is.
Yeah, it's like instead of force-feeding AI data, we're actually teaching it how to learn. like a teacher and student.
Right, exactly. And this is changing the types of problems AI can solve. We'll see AI doing things we thought only humans could do.
So more big breakthroughs coming soon, thanks to reinforcement learning.
Oh, absolutely. Another trend that Kimi shows is the focus on long context AI. Remember how Kimi can process tons of information all at once?
Yeah, the bigger the AI's brain, the better it can, figure things out.
Precisely. And we'll see this trend keep going. AI will understand even more complex information. Imagine what this means for language processing, translations, even science.
Whoa, AI helping scientists discover new things.
The possibilities are huge. And don't forget multimodal learning, training on different types of data like text A&D images.
Right, Kimi uses both text and images. That's why it can answer questions about pictures and do those visual coding challenges. It's got a better grasp of the world.
Exactly. And this will only get bigger. AI will interact with the world more like we do. Imagine an assistant that understands what you say and see. That's personalized help.
Now that would be something else. An AI that gets what you need.
It's exciting, and Kimi is leading the way.
Well, this deep dive into Kimi has been amazing. It's clear that AI is changing fast.
It is, and it will affect us all.
I can't wait to see what happens next.
Right.
Listeners, thanks for joining us as we explored Kimi K1.5.
It was great to discuss AI with you.
And until next time, keep exploring.